Hi, welcome to this lecture on modern cryptography. So in this lecture, I'm going to give you an overview of the building blocks of modern cryptography before we jump in later weeks and do individual sections on each one. So this is an overview of modern cryptography. So the first thing I want to point out is that modern cryptography is based heavily on mathematics. And the math is somewhat difficult, actually. But I'm not going to cover the details of the math in this class. If you want the details, because cryptography math is actually really fascinating, you can go to Wikipedia, and it's an excellent resource. A lot of good cryptographers have written a lot of excellent articles on Wikipedia about various types of cryptography, and you can get a lot of details there. But right now in this lecture, we're only just going to do a brief overview of the three main types of cryptography that are used to build modern cryptographic systems. The first type of crypto is secret key cryptography, also sometimes called symmetric key cryptography. The second is called public key cryptography, sometimes called asymmetric key cryptography. And the third is called a message digest, or sometimes called hashing. So those are the three types of cryptographic building blocks. Now, I want you to remember from previous lectures that most of our encryption techniques have an algorithm, which is what you do to the message when you encrypt it, and a key, which is a secret that you need in order to encrypt or decrypt properly. So most of our encryption techniques have both an algorithm and a key. Okay, so let's look at the first cryptographic technique here, which is secret key or symmetric key crypto. And this is a cryptographic technique where both people in the communication share the same key. In fact, this is what you would normally think of when you think of encrypting a message. So in this case, Alice has her secret message she wants to send, and she has her algorithm that she wants to use, in this case, a secret key algorithm. And she has her key, and she puts the key and the message into the algorithm, and what she gets out is a ciphertext, her coded message. So she sends the coded message to Bob. Bob takes the coded message and combines it into the algorithm with the key, and what he gets out is the original plain text message that Alice encoded. So in this case, Alice and Bob are both using the same key. Alice encrypts with that key, and Bob decrypts with that same key. Now, the second modern building block of cryptography is called public key or asymmetric key cryptography. And this is a cryptographic technique where both parties in the communication use different keys. Let me show you what I mean. So let's pretend that Bob has two keys. The first is his private key. It's a secret that only he knows. And the second is a public key, which is a key that he's willing to give to anybody in the world. Now, those two keys are mathematically related in such a way that if you encrypt with one, you should decrypt with the other. So let's look at an example here. So in this case, Alice takes her secret message that she wants to send Bob, and she has an asymmetric cryptographic algorithm, and she has Bob's public key. Now, she uses the key with her message, and she produces the ciphertext. She sends that ciphertext to Bob, and in this case, Bob's going to decrypt it using his private key in order to get back the original message. So it's important to note here that Alice encrypted with one key, and Bob decrypted with another key, and those two keys are not the same. They're not equal. So that's why we call it asymmetric cryptography. Symmetric means two things that are the same on both sides. Asymmetric is things that are different on both sides. So in this case, it's asymmetric because you use a different key for encryption than you do for decryption. So the third building block is called a message digest or hashing. And in hashing, we transform any arbitrary message into a fixed length number. And a hash function should be one way. So that means that if we have that we can take a message and we can easily generate its hash, but if we have a hash, it's really, really hard to find a message with that hash. So hashing is actually widely used in a lot of areas of computing, not just within security or cryptography, and so it's a good thing to know. Another thing I want to mention as we jump into this start on modern cryptography is types of cryptanalysis. And you may remember that cryptanalysis is kind of the science of analyzing and trying to break cryptographic codes. So the first type of cryptanalysis is called a ciphertext-only attack. In this case, the attacker has some ciphertext and he needs to decrypt it. And the ciphertext is the only thing he has. Now, he may know the algorithm, of course, because we mentioned before that the algorithm is not a secret. So the attacker has some ciphertext and knows the algorithm that was used, but doesn't know the key. If that's the case, we call that a ciphertext-only attack, because the only thing he has is the ciphertext. Now, a more powerful type of attack would be a known plaintext attack. This is where an attacker knows some ciphertext and its corresponding plaintext and wants to decrypt some other piece of ciphertext. So we say, well, the attacker has some plaintext ciphertext pairs and some additional ciphertext that he wants to be able to decrypt. The third type of cryptanalysis is a chosen plaintext attack. Now, in a chosen plaintext attack, an attacker can get any plaintext that he wants encrypted, and he uses that to help him decrypt something else. So you think of it as, okay, the attacker can choose any plaintext he wants, he can have it encrypted, and he can analyze that result in order to help him to decrypt some other ciphertext. So these are the three types of cryptanalysis, and we'll talk more about these as we go on in this course. So let's summarize today's lecture. We talked about three types of cryptography: symmetric or secret key cryptography, asymmetric or public key cryptography, and hashing or a message digest. We also talked about three types of cryptanalysis: a ciphertext-only attack, a known plaintext attack, and a chosen plaintext attack. That's all for now. Thanks.